Okay, here's a couple of fairly simple examples that we're going to do. Here we have this triangle here. This is one triangle. Let's break it apart, okay? Because we really don't have one triangle. We have two triangles. We have this small triangle right here, and then we have this larger triangle, okay? The outside edge, okay? So let's look at it. This triangle here has that angle. This is saying that this angle is that angle. So that means when we break it apart, this angle is this angle. Same measurement. This angle is congruent to that angle. This angle is congruent to that angle. So do we meet the first condition? Congruent corresponding angles. Yes. We have congruent corresponding angles. Now all we have to see is what? If the corresponding sides are proportional. Well, let's look at it. This one here is 11, this is 22. So what we've got is we've got 22 to 11 equals 2 to 1. So what we're looking at is everything on this triangle has to be 2 of this. Well, I've got one segment here that equals that. I've got one segment there. I've got two segments they both equal that. So that's 2 of these and 1 of those. So if we were to call this x, we'd have x there and x there. We'd have 2x over 1x equals 2 to 1. Well, let's call this y. That's y. That's y. We'd have 2y over 1y equals 2 to 1. Okay? So yes, everything is a 2 to 1. All the sides are proportional the same way, 2 to 1. So therefore, yes, these are similar. Yes. Similar. Okay? Alright, let's look at this one. We have actual measurements here. We're given what's in blue and what's in purple, and we calculate what's in black. We're given these two angles. We can calculate this. How do we calculate that angle? All the angles of a triangle have to add up to be 180. So subtract the 37, subtract the 27, you're going to get 116. So we have 37, 27, 116. Well, over here we have 37 and 116. What do you think this one is? Well, it's got to be what? Do the very same thing and you're going to come up with 27. So do we meet the first condition? Congruent corresponding angles. Yes, we have congruent corresponding angles. This goes to this, this goes to that, this goes to this. We just got to flip it upside down. Now, between the 37 and the 116, we have a 5x. So let's make 5x ratio with 4x. Well, what's going to happen there? The x's are going to what? Rules of algebra just say, oh, they're going to go to 1. Okay? Between the 37 and the 27, 37 and 27, we have y. So put the 10y over the 8y. What's going to happen to the y's? They're going to go to 1. Okay? And between the 27 and the 116, 27 and 116, we have 15z on this one and 12z on this one. This is simply going to go to here. Okay? Now, what happens to this one and this one? This is 5/4. If we take 2's out of that, what do we end up with? If we take 3's out of this, divide this by 2, 5/4. Divide this by 3, 5/4. So all of the sides are proportional, the same, they equal the same, they equal 5/4. 5 to 4. Okay? Scale factor between the two. 5 of these and 4 of these. Alright? This one's smaller by 4/5. This one's larger by 5/4. Alright? So we have congruent corresponding angles and proportional corresponding sides in both situations. So yes, they are similar. Similar, similar. Okay? Similar. Both of those are similar. Okay, we got a couple of more examples that we want to do. Let's look at these really close. Given similar polygons, find x and y, and that pertains to both of these problems, okay? We're given similar polygons. We're actually told these are similar polygons, so we are to assume, and we can believe that their what? Their angles are congruent, and their corresponding sides, their corresponding angles are congruent, and their corresponding sides are proportional. Okay, so let's mark this up. If we have two sets of angles that are congruent, what do we know about the third set? It doesn't have a choice. It's got to be congruent, doesn't it? This one right here, because we can take 180, subtract this one, and subtract that one, and we got to get that. Well, if this one equals that, and this one equals that, we take 180, we're going to get the same thing. Okay? You're going to know that as angle similarity. We're going to learn that in 7.3, called angle similarity. So, we know that that third angle is equal to each other. Now, what we're told is they're also, since they're similar, their corresponding sides are proportional. So, what do we know? We know that this 10 goes with y. Why? Because it's between the 2 and the 1. Between the 2 and the 1 is the y. So we know that 10 goes to y. We know that 9 goes with x, or x goes with 9. Why? Because it's between the 2 and the 3. So, same side, okay, we're going with the blue to the red, equals x over 9. Equals, we better have something that has some numbers that match, don't we? Between 1 and 3, between 1 and 3 on the blue, we have 8 is to 12. Okay, so we finally have proportion we can set up. We have 10 is to y equals 8 is to 12. We cross multiply. We're going to get 8y equals 120. Y equals 1 equals 15. So we can go here, and this says this equals 15. All right? Now let's do this one. X is to 9 equals 8 is to 12. 12x equals 72. X equals 6. So this equals 6. Okay? Now, let's see what we're looking at. So we come up with 10 is to 15. 10 is to 15 equals 6 is to 9 equals 8 is to 12. What does this reduce to? Take 5s out of that, we got 2 and 3. Take 3s out of this, you got 2 and 3. Take 4s out of this, you got 2 and 3. All of these equal 2/3. They have the same proportion. Therefore, all the sides are proportional. Because the sides are proportional and the angles are all congruent, they definitely are similar, and we can find the missing sides. We're going to do the same thing over here with this one. Again, what do we know about this third angle? If these two angles are congruent, this third angle has to be congruent with them. Okay? Now this one's a little easier to see. We know the x goes with the 18, 36 goes with the y, and the 40 goes with 30. So we're just going to come down here and put that up. X is to 18. X is to 18 equals 40 is to 30. Now, let's look at this. Would you expect x to be bigger or smaller than 18? Look at this. 40 is bigger than 30, isn't it? So x is going to be larger than 18. That's a reasonableness check. You need to be able to do a reasonableness check. It ought to be bigger. By what? Let me see, divide this by 3 and add it to that. Divide this by 3, add it to that. We think that ought to be probably 24, right? Okay, let's see what happens. What can we get rid of here? We can get rid of the zeros. 30x equals 4 times 18, 36, 720. X equals 720 divided by 30. Get rid of that. That goes into that. Equals 2, 4. Wow. So we come up with it, don't we? So x equals 24. What does this mean? This means 36 is to y equals 40 is to 30. We can do that. Now, would you expect the y to be less than or bigger? I would expect it to be less than. 4/3. What goes into 4 here? What goes into that? 4 times? 9. 9 times 4? 9 times 3. I would expect this to be 27. Let's see what happens. 3 times 36. Oh! 3 times 36 is going to be 9 times 12, so that's going to be 108. Equals 4y. Y equals 108. All right. Divided by 4. What do you get? 108. Oh, look at there. Y equals 4. No, it doesn't equal 4. Equals 27. So what do we know? This is 27. Okay? So we figured that out. Well, what are these proportions? We already know. What are they? 4/3. We take that 10 off of that when we've got 4/3. So we've got 4/3 equals 24 is to 18 equals 36 is to 27. What do we got? Take 6 out of this. 6, divide 24 by 6. You get 4, divide 18 by 6, you get 3. So that equals 4/3. Divide 36 by 9, you get 4. Divide 27 by 9, you get 3. You get 4/3. So all of the sides are proportional. We found what those sides are. This one right here is 27. This one right here is 24. And that's how you use proportions to solve similar polygons.